Hey everybody, this is Larry. This is day 29th of the June LeetCode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. 2 more days to go. So, give yourself props because these are tough and you need, and it's all about keeping a good pace versus grinding it. I mean, you should grind in the beginning, especially a little bit, but definitely in the end, it's always going to be a marathon, not a sprint. So take your time, pace yourself, and just give yourself enough time to absorb and learn, right? Because you can't deliver a baby. How does that go? You can't get 9 people to deliver a baby in 1 month. Whatever, right? So you still have to let your brain breathe. Have to let your brain learn and so forth. So definitely, keep that in mind. Today's problem is going to be max consecutive ones as we get into the third version of this as we get into the summer. Hope everyone's doing all right. Anyway, I usually start these live with a little bit of a random commentary, so feel free to skip ahead, watch it on 2x, whatever you need to do. Anyway, today's problem is giving a binary nums return the maximum number of consecutive ones if you can flip at most k zeros. Okay, so that's not that bad. So the first thing that comes to my mind is just going to be the two things. One is sliding window, and the other, or maybe not sliding window, because or it is. I think people conflate sliding windows with a lot of things, and I am guilty of that as well. But maybe more accurately, 2 pointers. And then the other thing is prefix sum. Though maybe not even prefix sum. Maybe you don't actually need it. I mean, maybe it'll help, but I don't think you need prefix sum. So actually, maybe I take that back about prefix sum. It's just that I've been thinking a lot about prefix sum the last couple of weeks, mostly because LeetCode has been doing a lot of them. So, but I think sliding windows is good enough. The idea behind the sliding window solution for this is just a greedy solution. And what does flipping at most k0 means, right? In this thing, the first thing I would do, other than all the things that we just talked about, I suppose, is thinking about what that actually means. Sometimes it means rephrasing or rethinking about it in another way. And what this means is just that, this property of consecutive ones and at most k zeros mean to me, when I first saw it, means that you have a substring in which there are at most k zeros, right? And in that sense, there's a sort of a greedy thinking about it in that, because in that span, in this case, you want to flip as many zeros as possible within that window. And that's basically the idea. And that's also why sometimes you hear 2 pointers or 2 fingers out of them, because you have 1 point on the left, 1 point on the right, and then just keep track of what's in the middle, right? And in this one is easy. When you see a 1, when you expand out, you see a 1, well, you add 1. And if you see a 0, well, you keep track of that as well. So that's basically the idea here. And let's get started with that, all that's being set. Yeah, and I think this is pretty good in that sense. Yeah. So basically, sometimes I also call this the quote unquote the implementation part, sometimes just called bookkeeping. And bookkeeping is not an algorithm. I am guilty of saying that a few times, where people think it's like something that you can Google and it's an algorithm or something. And what I mean that is just an English term. Bookkeeping means keeping track of a lot of things and making sure that every step of the way, what you think is true is still true. Or just like keeping track of things, I suppose. Sometimes you can also think about it as an invariant. I think it also probably comes from bookkeeping as in being like accountant, right? Like if you're an accountant and you're trying to keep track of your P&L, profits and losses, and you go, okay, today I spent $1. Yesterday I went to Chipotle and spend $10, and today I have my salary and got paid $200. So you gotta add that up. You keep track of it. So basically, the idea behind that phrasing is just to keep track of everything. And yeah, because I definitely get questions from time to time about what algorithm is bookkeeping, and I feel bad because I feel like maybe I'm just using too much American lingo or something like that. I don't know. Or nerdy lingo. I don't know. Anyway, let's get started. So basically with 2 pointers, I have 2 pointers, right? Let's just start with zero. We have a left pointer and a right pointer. Let's start them all at the same place at the beginning. And then we move the right pointer to the right. Well, we move both of them to the right, but let's start by keep moving the one to the right. And of course, sometimes you'll see this as a for loop and it's fine. But here I wanted to kind of, I think for loop is fine, but because it's just syntax at some point. But technically, I think a while loop can raise what I want to do more accurately. But yeah, so let's say now you have a window, you have whatever. And in this case, in this moment, it is exclusive. And what do I mean by that? It means that left is inclusive and right is exclusive. So if you think about it as a range, you think about it as something like this, right? So yeah, so then now at this moment it is exclusive, but then now as we process it, it becomes inclusive. So now we want to process num sub right, and what does that mean, right? If num sub right is equal to 0, then well, let's keep track of zeros then. And because that's basically what we have to do. And if I am doing this as I'm building out the code as I'm going through it, because I want to kind of show my thought process toward that. But of course, with practice and a lot of practice, maybe you kind of know what you want to do and what you want to keep track of. Then it becomes easier to kind of write the code, quote unquote, linear, like from beginning to the end. So now we want to keep track of zeros, right? So yeah. So zeros plus equals to 1, and then here's the part about the invariant, right? Because we only can flip k zeros. If we have more than k zeros, then we have to move the left. We have to reduce the left side so that our segment, our window, has at most k zeros. So let's do that. So while zeros is greater than k, num sub left. If num sub left is equal to 0, 0 is minus 1. And then regardless, you move the left pointer. Oops, typo, don't get confused. But yeah, and of course this loop, sometimes I also get questions about when I see these kind of loops, like wouldn't this get into infinite loop? Can you be sure? Well, this is the part where like there's some kind of forcing or invariance where, because we know that left is going to be less than right no matter what, no matter what. The invariant is such that as left goes from left to right, so to speak, as left increments, this zeros goes down, and zeros can, and as zeros goes down, even in the most minimal case, when left is equal to right, zeros is going to be 0, and this is always going to be forced. So that's why that's not an infinite loop. But yeah, and then now we have a left-right inclusive range such that we have k or fewer zeros, right? Because now, yeah, if you think about the range and how it moves and stuff like that, that's going to be true. And then now that we have this happening, well, now we just have to count what is the largest segment, right? Yeah, the maximum number of consecutive 1, which is the longest segment. Now that we have a range, we flip everything inside to 1. That's effectively what this does. And of course, when you look at this code, or if you look at other people write these code, it's like 10 lines of code or whatever, and it looks very compact, and there are a lot of assumptions built in. So I'm just talking through what that assumption looks like. So what is the length of this range, or the consecutive number of ones, right? So that's just going to be right minus left plus 1, because this is an inclusive range. And you could kind of, if you do get you need to take a moment to kind of convince yourself, do that. I also am really bad at kind of getting off by ones and stuff like that, and sometimes I need to step back to think about the plus 1, minus 1, or whatever, right? And the thing that I think about sometimes is just like, okay, if if this is an inclusive range, what if right is equal to left, right? If you have a range of one number, then it's just going to be 1. So if they're the same, that's going to be 1. If the delta is 1, then you have two numbers. Like if it's 1 and 2, then you have two numbers plus 1, 2, right? So that's basically some stuff that I sanity checked to make sure. So this is the current range. And then now we just have to check it with some best variable. So let's say our longest length is equal to 0. And then now we just do, and this is of course a shorthand for if this number is bigger than best, we set it to best. And that's pretty much it. I mean, unless I made a typo or something, that's pretty much it. Let's put in more thingies. Oops. Pay to win. Yep, it looks okay. The only thing that made me worry about are the edge cases. I mean, I'm not that worried about it actually on this case, to be honest, but it's always fun to kind of test these cases. Just give it a quick one, especially that you have an expected answer, you could actually check it. On a contest, obviously you're not giving an expected answer, but you know, I would check 0 and kind of weird bounds and edge cases just to make sure that I don't have any out bounds or anything like that. In this case, I'm actually confident, but yeah, so this is accepted, and I think I actually skipped going over the complexity first because n is actually 10 to the 5th, but knowing that I had this algorithm knowing that it's going to be linear time, to be frank, so I didn't look at constraints that much because linear time is going to be fast enough because that's the lower bound because you have to look at each number at least once. So, okay, so yeah, like I said, this is linear time. It may look confusing because there are two while loops, but you can think about them independently, even though they are nested, because if you look at this pointer, the right pointer, it can only move to the right n times, and this moves the left pointer, and the left can only go to the right n times. So it's going to be 2 times n, or O of n, so linear time. In terms of space, well, you could just count, right? There are only constant number of variables, there's no arrays or anything usage like that. So it's going to be linear, constant space, misspoken. But yeah, that's all I have for this one. I think one more thing I want to say, and I get this a lot, and I've been really bad about saying that because the problems recently has been too hard for interviews, so I just kind of assume that people understand. But yeah, but for this one though, this one I would say is probably within the realms of, yeah, this is definitely interviewable if that's the word. So definitely make sure you're able to do sliding windows, a sort of greedy, and these kind of things in between, and give yourself more practice. Maybe even do max consecutive ones, 1 and 2 or something like that. But yeah, that's pretty much all I have for today. Happy Tuesday. Hope y'all are doing well. Let's finish the end of the month. Stay good, stay cool, stay healthy, to good mental health. And I'll see you later. Bye bye.